Where do you get the help?
Yeah?
Where do you get the help?
What?
The offline help.
Oh, you just click on help. There's a help there.
Yeah, but
let me. Okay, you'll come to, in case you want to get the offline help, you just come and hover over the function you want to see, you want to solve to use, like what I'm doing here. Then you see these arrows here.
Yeah.
This one here shows you various methods of using it, or how it is applied. Then this eye here takes you to the offline documentation rather. Let me first get back to it.
If you don't type it,
yeah?
If you don't type it.
Or if you don't type it, you'll have to go and search. You'll have to go and search from this side here. We got help. We're now going to what? Sampling distribution. So you see, help, we have Wolfram documentation up here. So let me go back to downloading what? Installing EasyFit. But you can sample distributions, and I think that will be most of it for today, plus then in the Friday session we shall meet to do what? Monte Carlo, and then wind up Monte Carlo simulation for both MATLAB and Mathematica. Then what? Yeah, plus that too. But we did LCS in MATLAB, eh? Yeah. So Friday session we shall finalize with those 3 items: LCS in Mathematica, then Monte Carlo in both MATLAB and Mathematica. Then I believe you'll distribute the paper from what? From our year, yeah? The one that has the Monte Carlo simulation number. That has the questions on Monte Carlo simulation. The one I shared with you guys last year. So they're there. You'll send it to me. Yeah, you'll send it to me. So to install EasyFit, you just click that setup file, and then you click yes, and then give it some time. You click English, okay? Yeah, the language. Click on next. My network is a little bit slow. There's no virus. If and for what? And for loops. So the control statements. So as this downloading, we can first go and handle the for loops and if statement in what? In Mathematica. So last time, I remember there's a time we went through that in class. You guys all break your silence. Just avoid the noise. Eh? So we're having control statements. So the most common ones that there are various control statements, but here we shall handle the if statement and the for loop. Eh? We shall handle the if statement and the for loop. Although there are various kinds of loops, you have while loops and then do while loops. They all do the same thing, but in different ways. But for simplicity, since you're not doing programming or anything, just use the simplest loop. So the if statement is more of what? It's used for logical programming. Eh? used for logical programming. So it's more of making decisions, enabling the program to make a decision. So how does it work? How does it work? So hopefully you can see that that whiteboard. So you remember from basic math that you had a flow chart that was something of this nature. So what this is going to incorporate, both the if statement and the what, and the control, and the for loop. So basically, how the for loop works is that you have your start point. So you had your start point, and then somewhere here is you entered a particular value of say n. Then here you came and tested the condition. As a condition here, and then in case the condition was satisfied, what would you do? You would you would go on to evaluate, and then print and stock. Then in case it is not, you go back and change the value of n.
Yes.
So now that process of that entire process of deciding whether to go back or whether to go to the end point. Okay, at this point where you see this move, the weird rectangle here, this is where you have the if statement working, because you're testing a condition, because you had that you had more of a condition that say if say n is greater than 4, something like that. So you test the statement and say what happens if n is less than, if n is 1, you would print it out, right? Then if n is 2, you still print it out. Wait, this one is only interested in greater than 4. If n is greater than 4, let's say 1, you don't, 2, you don't, 3, 4, you print it. No, it will not. Just change this. Change this. So you start from n is equals to 1, you print it out, 2, you print it out, 3, you print it out, but once it reaches 4, you find that that condition can no longer satisfy what? It can no longer satisfy this, because from 4, you go to 5, and 5 is not less or equal to 4. So at that point there, you terminate the loop. So wherever the condition is no longer being satisfied is where you terminate the loop. So let me go back and share the screen and write the code. So yeah, it's used for logical programming. So what's the syntax? We shall write a basic code, something simple as we did in MATLAB. So we could say mark is equals to, let me start with the syntax. The syntax of, but hopefully you guys are following along.
Yes. I'm going to get that help.
Yeah, I'll show it to you. So the syntax for if in MATLAB is that, or rather Mathematica, the first letter is capital, then you put in you open your square bracket. You open your square bracket, and then first you start by putting the condition, comma, and then once the condition has been tested, what do you want it to print out? The true statement. And then if the condition has not been met, you want it to print out the what? The false statement. So that's the structure of a for loop. Eh? So we shall comment this out. That's the basic structure. Then we can now do some code, some simple code, just to test whether person A has either reject, passed, or failed, something like that. Eh? So we have mark is equals to say, let's give it 55. So here we are hard coding the variables. Eh? What I mean by hard coding is that the variable you can only change it manually. Eh? But along the way, we shall see how to do it in a simplified way, whereby it asks you to enter the value and then to evaluate it. So one test whether this guy has actually passed or failed. Yeah? So if the condition one test is if mark is greater than 50, what do you want it to print out? Yeah. Say first. Then else if it is not. Yeah. Want it to print out so now you must take care to close all the brackets, because you realize I opened this and I've closed this. Then the second bracket finally closes it all. Yeah. Now I can run my comment and you see. So mark is 55 and 55 is greater than 50. So it prints out this. Now what happens if I change this to say 45? You see, retake. So basically, yeah. Any question?
So let's imagine we have like three.
So yeah, we're coming to that. Eh? So now this is what's known as this is the basic structure of a for loop. Eh? But then there are cases where you'll find that you're testing more than one condition. Eh? Testing more than one condition. So in that case, what will you use? In that case, you'll have to use what is known as a nested if statement. So it is an if statement within an if statement, just like we had lists. We had a list within a list. So we shall use a nested if statement. So how does it work? I'm going to put up the syntax so that you can see. So the syntax. So the syntax of a nested if statement is that you have your first condition. You have your true statement, false statement. And then now within this, you open. You now put a comma and then open another if statement. Put in another condition. And then you have your true, false. Then yeah, you'll have to close both of them. So it is something like that. Just make it structured. Condition. You have your true.
Small of repeating the same.
Yeah, but yeah, just make sure it is within the original. So something like that. Yeah? So that would be the structure of a nested if statement. When you're testing more than just one statement, because here we're testing just one statement. Yeah? That's why we only have that. So let me close this. That's a syntax of our nested if statement. So now assuming, yeah, I'm now testing. Let me put in mark. Let me put something, say 55 for now. Then I want to test the 3 scenarios. One, the case where the person is below 50, that will be a reject. Where he's when say he has 50, that is maybe telling me survived narrowly, and anything above 50 tell him that he has passed. So those will be 3 instances. So what I would do, I would now come and say, if open my first bracket, so enter my first condition, mark is less than 50. So I put my comma and I print out. For the guys online, I think we're remaining with one more concept. So I think the next session is the last session. Yeah, but it will be a short one. Or we can do the remaining session on Friday.
Yes.
Yeah, so we make this be the last session, right?
Yes.
It's fine. You guys are saying yes to the energy. Yeah. So if it is less than that, we say you have your retake. Okay, then first of all, don't write. I'm just testing it out. First wait. Just testing it out. I think that Mathematica is a little bit loose. Can forget the syntax quite easily. Survive narrowly. Yeah, that's how I've been surviving. And then the last one. So just hold on to write and just testing the syntax. After this, you now close the brackets. So this closes that first bracket here of the if statement. The second bracket closes the second if statement. The third bracket closes that. So let us test this out. So now the mark, we have the mark as 55, and 55 is greater than 50, so it has printed out past there. So what happens if we change this to 45? So you see, you have your retake, and what happens when you change this to 50? Yeah, survive narrowly. So this, what we have used here, remember in MATLAB we covered something to do with the if-else if statement. So this is the equivalent of that in what we had the other side in MATLAB. MATLAB you had if, else. Yeah. So now here in Mathematica, it doesn't give that option. It uses a nested if statement to do that comparison. So I think down here I'll add Instead, I'll put some, say something this is equivalent. It's equivalent to the if statement in MATLAB, something like that. So I can now go in for the last part that we're doing, the for loop. So realize that most of this has been a discussion actually. So we're going in for the for loop. And I described to you what's the purpose of a for loop. So the purpose of a for loop is to iterate. I'll use hard words. Iterate a code block. A code block, say n times. What I mean by iterate is stroke run, say repeat, yeah, something like that. So the format of see. So how the for loop is it's that you have the for, the syntax. Let me just say syntax. And I can type it. But hopefully you guys are picking up. I don't want to be shocked tomorrow that you guys aren't understanding that from the first statement of MATLAB, I've not understood.
Since last semester.
So the syntax is that for a for loop, you have that you have a start, and then you have the iteration. Okay, I call it interval. Let me call it interval. That is in what? That is in MATLAB. So in Mathematica, it is you have the start, and then you have it's more of like I'll call it body, and then finally you have the iterator. That's the syntax I would give. Put this up there. So how does it look like in so you start with a for keyword. So you see, you open square brackets, then you start with the initial point, I is equals to say 1, and then the body is usually like it's usually like the extent of how long you want the program to run. Like do not cross like this limit. That's more of like what the body has to do. So let me comment this and say I put a comment by the side and say start. Then next I say I is less or equal to 25. And I comment this out and say body. So I'm sure you're now seeing the difference between MATLAB and Mathematica. Then I++ is the iterator. So the purpose of the iterator is so the iterator simply I would define it as enables continuation. Yeah, let me leave it as that continuation. Hopefully that's the spelling. Something like that. So that is it. And then after this, we can now go and put in say we want to print out the first 25 natural numbers. can now go and say print. We just say print I. So we shall, let me first give this a test and see. Yeah. So it prints from 1 up to 25. So that's how a for loop works. Yeah? This is the basic code, the most basic code that you write for a for loop. But how we apply this in, as you say in MATLAB, we apply it in the linear convolution scheme. We applied both the if statement and the for loop. And then in our next session, Friday, we're going to do, we shall start with a linear LCS in Mathematica. Then we shall do sampling distributions in Mathematica. Then we shall see it off with Monte Carlo in both MATLAB and